I need to turn this.
Right.
Okay, we're live. Hey y'all, we are live right now, so if you don't want your mom to hear it, don't say it.
This is being broadcast. I
think. So yeah, we're why am I getting? Anyway, we're live right here. It's going to give us a talk on forensic. So thanks, Andrew. Yeah.
Ukrainian plane shot down, and they're talking about
Russian grocery stores.
Yeah.
You know they're really cheap flights to Moscow. I bet there are. And there's 24
Hey, this shows you as
Moscow.
Yeah, I'm looking at it here. I'm just trying to figure out where this is.
But you gotta get a visa. Right?
Well, not a full visa. You only
How'd
need
you find it?
A transit visa.
transit visa. And those are good for 72 hours in Moscow without any extra hassle.
So you can leave the airport.
You can leave the airport,
see sites,
and as long as it's not over 72 hours, it's not that big of a deal. But you still have to get it in advance.
Right.
I've never been, but every time I've looked, my business partner that once he's been there before, he's like, you know.
I'd like to go to St. Petersburg, go to the Hermitage, and like see some art collections.
Yeah,
like
unfortunately,
Moscow,
the $900 round trip flight
Where's
goes to Moscow with a 23-hour layover.
$900? Wow, that's expensive.
Well, if you leave from Fort Myers, Florida, and come through Atlanta.
You're probably gonna get $900.
Where's
almost $900 in Sky Miles from the ticket.
Oh, I have no Sky Miles.
How do I know what link to
I don't
post?
even use more Sky Miles than that.
I guess it's this one.
I only did like 70,000 miles last year. I don't really fly in the U.S.
Really rained on my mind.
All right. Well, I think I'm sharing something, but I couldn't.
My mileage not.
Oh, this is.
No.
Are we using Spectrum in your crash?
Yeah.
Oh, wait a minute.
I think you started. You just spelled Rekall.
I think it's showing. Well, here's what I'm seeing from you.
That's the
maybe not. Yeah, I was sharing the video.
Actually, for now, that's
Oh, yes, that's $1. We can get that broken. Like, I mean, like if you get a cheap flight, you're like,
Oh, sorry, that's me.
No, you get redemption value for the amount of money you spend. So if you get a cheap flight.
Yeah, the way it works is you don't lose any status. I'm really big guy.
How do you find the app where it is on YouTube? Broadcast?
He just got back here. Yeah, they've been going around there. Yeah, I went out and worked for well, here. So I didn't spend. I didn't spend $700 for the airfare last year. Wow. So yes,
Come on in, the water's great.
Did
You see that truck? I don't believe you.
I want to share the slides.
So this year is so transparent.
Yeah, I was. Yeah, the slides. I see. Right now, I'm seeing your smiling face on your computer. Well, I see your eyes, basically. The angle for your webcam is. Yeah, so I can see you on your webcam.
Yeah, it looks like I'm going to be able to get the screen going.
No, I actually. Yeah, I don't Okay, so I need to do this. You want me to reintroduce you?
Almost as now because I'm not convinced of all the other
Okay, we finally got the hangout working, so Everett's going to do basically to talk about it. So thank you all for coming. And for those of you who are in the cheap seats at home via Hangout, we tried to share the desktop so you can see the slides, but it didn't work. I'll see if I can get some of them on the camera. So thank you, Andrew. Go for it.
Cool. Yeah, I'll definitely send the slides out. The live demos, well, you probably don't want to see those anyway. We'll see how it goes. All right. Hi, everybody. Hope you had a good breakfast. This presentation is part of the overall education effort that a few of us have embarked on. The theme, if there is one, is go hack something, learn something, and then share what you figured out. So I am definitely not a forensics expert. There are actually some in the room, but I won't point them out. Okay, somebody else will point them out. I have learned a few things, and I think that gives me a pretty good perspective on helping other people who are not yet experts get started and learn some stuff about a pretty fascinating field. So this is the silly title, which is Sift Your Security Onions Carefully and Recall the Order of Volatility Before You Autopsy. And everything in bold is the name of the tool we're going to talk about.
There a total recall too?
All of the recall project stuff, there we go, is done with screenshots from a particular Arnold Schwarzenegger movie, if that's what you're asking. Here's the slightly less silly title. This is Learn Digital Forensics with Free Host Forensics Tools. And you're at DC404 in July. This is a quick menu. We're going to talk about forensics and forensic science a little bit, and we're going to look at a bunch of free tools. I'm going to try and demo a few of them if the gods are kind, talk about some places you can get some evidence from to practice on, and then close it out. So we'll start with Wiktionary, which is as good a place as any to get definitions for words for presentations. They have 3 posted definitions for forensics, and I wanted to put them all up here because it's a big word that a lot of people use to mean a lot of different things. This first one is the most common and probably the most technical usage, relating to the use of science and technology in the investigation and establishment of facts or evidence in a court of law. That's a pretty common, well-understood definition of what forensics or what forensic science is. An older definition, number 2, is just pretty much anything having to do with courts or law. And then the oldest definition, but I think one of the more interesting ones, is relating to or used in debate or argument. And this is actually where you see the forensic society or debate club and school competitions. But it's all kind of the same idea, right? You're trying to construct an argument to convince somebody of something, to win a case, you get a decision.
Me, bye.
And of course, forensics is all over television shows. There's all kinds of shows. In fact, there are now shows dedicated to criminalistics and crime scene investigations. A lot of the stuff on those shows is forensic pathology, where they're looking at dead things to figure out how they died and what can be done about it. I list a whole bunch of shows up here, which probably tell you more about my taste in telly than about how forensics is portrayed on television. We got Bones, CSI, Dexter. Dexter actually is a forensic analyst, a blood splatter specialist. There's all kinds of forensics in Doctor Who because the humans keep dying. NCIS, Ducky is a forensic pathologist. Twin Peaks starts off with a girl in a body bag. That's forensic pathology. Quincy MD, you guys are probably all too young to know that show, but it was a show about a guy who was a forensic pathologist. What was it? Jack Kirkman? Kirkman? Yeah, sorry. Yeah. He's gone now. But, he was an amazing actor. Torchwood, a Doctor Who spinoff that also has a lot of dead humans, and they actually do some of their own forensics in the classroom there. And of course the X-Files, where they do forensic analysis of all kinds of things that might not be human. No spoilers. And of course pretty much every cop show, every police procedural, and almost every show about serial killers or movie about serial killers since Dragnet or before includes some kinds of forensic science. Usually this is forensic pathology and blood and dead biology, but sometimes with more recent shows they actually do some digital forensics on these programs. And they always do it badly.
Write a BB script, do a pink trace or something.
I won't tell you which senior SecureWorks leader asked us to see if we could get that to work.
Get what to work?
Find the murderer Visual Basic script thing. Yeah. That email thread was lost to time.
To protect the entity.
So one of the most established and successful authors and tool creators in the field of digital forensics, particularly on the open source side, is Brian Carrier. He's not here. Gotta watch out for that sort of thing. He defines digital investigations as developing and testing hypotheses about digital events. And I think this is a really great definition because it focuses us back on science and how we use science to find things out about what happened to or on computer systems. So this is the science of examining evidence to find out what happened, when it happened, how it happened, who did it. You don't usually get to figure out why, right? Motive is not often something that comes up in digital forensics. It's not that we don't speculate about it or try and figure it out. It's just that's not usually in the evidence, except in chat logs. And we do this by proving and disproving hypotheses with evidence. And this is a picture of Ryan's book, File System Forensic Analysis. He also wrote some of the tools we're going to talk about. Here's the IANAL slide. I'm not a lawyer. I'm not your lawyer. This is not legal advice. You shouldn't take any from me. Carrier and a lot of other authors distinguish between the use of forensics techniques for legal proceedings and criminal investigations with the use of those techniques for basically anything else. And he actually contrasts the terminology with digital investigation, which is his preferred term for the whole field, with digital forensic investigation, which are focused on legal proceedings and what the lawyers need or what the court needs to see. I just talk about forensics versus capital F forensics, and mostly when I'm doing that, it's because I'm saying I don't do capital F forensics. I use forensic techniques to investigate a case, to try and find out what happened, and to inform the client or the organization as to what they can do about it, either in a response effort or in some kind of HR thing. Which is one of the reasons. Yeah, Georgia's not the only state that has that little wrinkle of law. If you are designing forensics programs, if you are learning and practicing forensics techniques for the law, work with that lawyer. Find out what they need, then do that. You will need a lot of skill and science and a pretty impressive technical background to get into that part of the work. There's a joke here about the dress code. And it's pretty cool stuff. There are actually some folks in our group, maybe not here today, that actually do that sort of thing on a regular basis, make a pretty good living at it, from what I understand. But the focus of the work and the constraints around what they do and how they do it is very, very different than the kind of forensics that I do, or if I may, some of the experts at CTU or some of the Foundstone folks here.
Yeah.
Yeah.
I don't think there's any Foundstone folks here anymore.
Weird. I figured there'd be at least one of them here to heckle me, or that Scott would show up and tell me I was telling you everything wrong.
Right.
Well, because he didn't show up, he has no leg to stand on. So
I'd still have to
start
refer
doing
to
something from your computer on Google Plus.
Yeah.
His talks
Yeah.
online.
Well, yeah. So here's some core forensics principles. And as you'll see pretty quickly, these kind of come equally from law and from science, which is one of the neat things about the field. From the law side, we have to worry about evidence integrity and chains of custody, as well as the rules about and the different types of evidence. And an important thing, particularly in the U.S. system, is the adversarial system of justice. This is really, really important. From the science side, of course, we start with the scientific method. We work to create reproducible experiments that somebody else could do and hopefully get the same results. And we take really, really detailed notes about what we're doing, what we expect to find, what actually happens, and we generally are thinking that we're going to publish that stuff. Even if not everything we do gets published, we have that in mind when we're taking notes and when we're putting things together. So from the law, we have evidence integrity. This is a really, really big deal. In digital forensics, it is perhaps the most important point is to not alter the evidence if you can possibly avoid it. Hashes can sometimes disprove that this happened, which is why so many forensics people are so happy about hashing everything. You start to wonder why I, might hash all of my emails or all of the text files associated with a case or something kind of silly sounding like that. It's because you can never have too many hashes, really, until you start hashing really big data files. Sorry?
Hash the hashes, too, just be careful.
Sign the hashes, but yes, you're on the right track. And the detailed, really hard to get, this is where the professionals differentiated part of this, is most of the time you can't not alter evidence. And we'll talk about that more in a second when we talk about volatility. But you have to understand what changes you make. When you are gathering evidence, when you are responding to events, anything that you do is probably going to make changes. You need to understand what those are so that you can bring those into your analysis and explain them. There's a lot of stuff about the rules and type of evidence. This is pretty much like intro to legal system law 101 stuff or pre-law stuff, if you're going that way. And of course, some of it's jurisdictional. So like the federal rules of evidence are pretty good throughout the United States, but there's state laws, local laws, municipal laws, all that fun stuff. There are different kinds of evidence. Sometimes you can't present real evidence. Sometimes you can't present direct evidence. You always want to try and present best evidence. And of course, the chain of custody, which is a huge thing for digital forensics, especially since so much of the stuff that we're trying to bring along and analyze and make statements about is, well, fictional is a strong word. Let's say it's ephemeral or imaginary, if you will. At the very least, it's very, very sensitive, right? Most of the time, we're talking about a pattern of electrons in an extremely specific configuration in a piece of metal or ceramics or something. And you get into all kinds of crazy stuff. There was a really neat thread on DFear list in the last week or two with people talking about how the heck can you successfully capture a modern cell phone in a criminal investigation and keep it from being modified before you get it to the lab. And there's this great discussion about putting it inside a Faraday bag, and then putting that in a case that's lead lined. Should you try and take the battery and the SIM card out? Oh, wait, Apple. Okay, so you can't do that, so more Faraday bags. And, you know, some really, really cool discussion about the kinds of changes that are going to happen and, you know, the lock codes and whether or not you should let the phone lock before you try and acquire. No, by the way. Most modern mobile OS platforms, Apple included, if they have encryption enabled and you let the phone lock, you are going to have a lot more trouble getting the data out. And the adversarial system of justice, which is this fairly nutty idea that no matter what the issue of law at hand is, both sides are supposed to get a chance to present an argument. And there's a lot of rules in place to try and make it so that there's some equality between their ability to present that argument. Oh, I'm terribly sorry. You guys just yell at me when you come up behind me and I don't see you. You're more important than the presentation. House rules.
Yeah. Well said.
And the adversarial system of justice is the idea that there is counsel or an attorney for both sides, and they both have access to the same evidence. For forensics, that's the key point, right? If what you're working on actually did really go to court, the other side is going to get all of the same evidence that you had. They're going to have another guy do all the same analysis that you did, and they're going to try and make it all come out a different way. This is very significant, and it's a huge, huge problem in a complex forensics case. At which point, if Scott were here, he would probably be crying. Because I know he's had to deal with this stuff. It is as crazy as the fact that there are professional organizations for people who assist in criminal investigations and forensics and legal stuff, just for people who work for the prosecution or just for people who work for the defense, because it's that significant. So from science, we get the scientific method, observation, hypothesis, experiment, and then revision or publication, V1. We have the idea of reproducible experiments. This is a really big deal in digital forensics. You're going to do the same analysis again with the same tool and really hope you get the same result the second and third time, right? Okay, so far so good. Okay, do the same analysis on the same evidence, hashes, right? Same evidence, different tool. Did you get the same result? Okay, why not? What does that tell you? And of course, from the adversarial system of justice, as well as from peer review in science, if somebody else does the same analysis with the same tools or different tools, same evidence, they get the same result. And these are the kinds of things that guide your thinking when you're trying to figure stuff out and when you're trying to decide what you can reasonably conclude from your findings, right? And of course, we have careful, detailed notes and precise reporting. This is part of being in science. Whatever field of science you're in, you have to keep track of what's going on, especially in your experimental environment, right? You have to know what your controls are and the other variables and so on. And we anticipate peer review and critique from our peers, even only on one side of the courtroom, to go back to the legal idea. So here's a couple of core forensics theories. There is a lot of theory to forensic science, both within and outside of digital forensics. These are a couple that I'm going to touch on today. They match up pretty well with the tools that we're going to look at. Is it Rekall or Rekall? Anyone?
Rekall.
Is it a hard D? Je ne parle pas français. So I have no idea.
I don't know, we'll go with Rekall since it's close to Rekall.
Sure. So Dr. Rekall, incredibly famous French police scientist, sometimes called the Sherlock Holmes of France, which is significant because Holmes is a fictional character, right? He's a comic book superhero. This guy was real, but people thought he was about equivalent of Holmes. He actually founded the first police lab in the world in Paris and made countless contributions to forensic science and criminal investigations. One of the things he is famous for saying is that every contact leaves a trace. Right? This is hugely important. Anything that anyone does on any of the digital systems that we're going to investigate makes changes. And a lot of times, there's actually interaction and transfer between the agent of change and the thing they're interacting with. The physical example of this is on CSI when two cars hit each other and they talk about paint transfer, right? The red car hits the silver car, how the silver car has some red paint in it so we can match up what happened. A lot of stuff like that happens in digital forensics, especially when you start to look at network forensics and computers talking to each other. Everything from two machines in a TCP conversation influencing each other's SYN and ACK registers to a lot of much more complicated and much more significant things. And Harlan gets into this a lot in the introductory chapters in Windows Forensic Analysis. He's not here either, right?
It does work on CTT now.
Yes, but not in Atlanta, as I understand it. Yeah. Really, really great book. So this is the principle of exchange, or Rekall's exchange principle, and it's incredibly important. And the other one I wanted to highlight is the order of volatility, and this is crazy cool and really important. And the idea is that you have to understand what's changing when you are looking at something and you're not doing anything yet.
Watch my hand.
Yep, just yell, really. Like clear, make a hole, anything like that. Especially with a live computer system, right? Even if no user input is taking place, all kinds of stuff is going on. And the order of volatility tells us to stack up the things that we might want to capture, the evidence that we might want to preserve, by the order of how fast they're changing, or how much our actions are going to change them. Harlan calls this out in the book, but he also refers back to this amazing RFC that I hadn't heard about before. It's 3227. It's all about digital evidence collection for cases and investigations. This list here to the right is actually from that RFC. And as you can see, at the top of the list, they talk about the registers and the cache. The actual transistors on the die of the processor are changing right now on all the computers. And then, of course, we get to the in-kernel tables, like the routing table and the process table, and then, of course, to memory itself. Memory is always changing. Temporary file systems, like a RAM disk or swap. And then, of course, anything that's actually going to disk or drive storage. But they keep going, right? It's not just the stuff on that system that you might be interested in to find out what happened there. There's the remote logging and monitoring data that's off somewhere else in the network, hopefully somewhere safe if security operations did their job right. And then there's the physical configuration and network topology of the system, which may still change depending on how long it's been since you actually tried to start your investigation. Or if it's a mobile system, it may be changing rapidly. This is what the order of volatility is all about. You have to stack these up for every system you're investigating. This is not the order that's always true. The other half of this is that capturing always alters volatile evidence. The simplest example of this is how do you capture memory on a computer, or how do you capture the disk on a running computer?
You start a new process in that same memory.
You run a program which does all kinds of stuff on a modern operating system. Sorry, I didn't mean to step on you. It's absolutely correct. It starts processes and threads, allocates file buffers, loads itself into memory. That's right. The program that you ran to copy everything in memory is now in memory. Don't think about it too hard. You might. And the order of volatility is just the theory, the principle that you have to understand all this stuff when you're deciding what your processes are going to be, and certainly when you're designing tools for other people. So here's some of the skill areas or roles in digital forensics. At the first level, and probably the easiest, though it can still be pretty complicated, the idea of being able to get the evidence safely and correctly using acquisition tools and following process, doing paperwork, it's vital. It's not only able to do acquisition, but they also run quick tests and use simple automated tools to try and find out stuff about evidence. Moving on from that, we have analysis. Forensic analysts can be expected to run multiple tools or even write tools or modify existing tools as needed. This is also the level where we would see someone who, having encountered something in a case that they're investigating, will go back to their lab and try and reproduce the same events on a system that they completely control to test out their tools and their understanding of the phenomenon. And then the top tier, at least on this slide, is reverse engineering. This is where, well beyond system or even program analysis, we have people who take a program apart entirely to find out what it's doing, and they'll either return a complete description of the program's behavior or reconstructed source code, or both, depending on what you need. The specializations in digital forensics mostly differ by the source data type. They share a lot in theory and process, but they may use completely different tools depending on what the platform they're working with is. And then, you know, they kind of link up Voltron style when you have everything available to fill in blanks in your case and slay monsters. Here are some of those specializations, which we're not going to try and cover all of today. On the hosts forensics side, we have disk forensics. That's probably the most obvious and most familiar to everybody. Physical and magnetic, optical, and even sometimes logical media. There's also memory forensics, where we're dealing with full or partial memory capture from devices and computers. And the specializations there tend to be platform related, either hardware platform or OS platform. So you'll hear people talking about Mac forensics utilities or iPhone forensics or something like that when someone has specialized skills or abilities in that area. Broadening out the scope and getting more difficult and more complicated and more advanced, we go to network forensics. This not only deals with what happens on individual hosts, but also what happens between them in the packets and network traffic and the logs. And there's a lot of other ways to look at network forensics besides those, including net flow, statistic analysis, and a few others. And then encompassing all of this in terms of skill and in tooling and difficulty is malware analysis, where you're looking at some number of computers that have been compromised or that have something bad going on, and you're trying to figure out the totality of what's happening across multiple computers, not only looking at the disks and the memory and the network information, but also the binaries themselves and the programs, trying to figure out what they did and why. And this goes all the way up to actually having to reverse engineer some of the software. All right, enough theory. Let's talk about some free host digital forensics tools, and then I'll try and demo a couple. So here are some really popular and awesome disk or drive forensics tools. The Sleuth Kit, Autopsy, and Lazo. The Sleuth Kit was actually originally written and still maintained by Brian Carrier, the guy who wrote the book that we were looking at a second ago, and is itself a descendant of TCT, the Coroner Toolkit, which was written by Dan and Vitsa, who pretty much founded the entire field of forensics on Unix systems. They're still kicking around senior chairs at conferences and publishing a paper every now and then. The Sleuth Kit is, at first, a whole bunch of command line tools in their library for doing drive and artifact analysis at every level. Not only can you look at file systems and volumes and partitions, but you can also look at individual files and directories, and also at individual blocks, inodes, and clusters, depending on what your evidence supports. But all the tools are there. Some of the tools included in the Sleuth Kit are MMLS and FLS, BlockCat, FSStat. If you're at all familiar with how Unix people name their commands, you can figure out what almost all these commands do. They're very, very low level and very powerful. There are also commands built into the Sleuth Kit for recovering deleted files, or just listing out all of the unused inodes in a file system, all kinds of amazing stuff like that. And of course, MacTime, which is pretty much the granddaddy of all timeline analysis tools. And they're at sleuthkit.org. This is that's their logo, the bloodhound there. And then this is a little picture of me running MLS against a VirtualBox hard drive of Windows 7. And you can see the partition table, because one of the things that MLS does for you is it tries to determine the format of an image and then give you the partition table if they can read it. This is really helpful because a lot of the other tools that you have to run, you need to aim them at a slice of the partition.
Philly cheesesteak.
Philly cheesesteak.
They're so polite.
I know. Just shout out.
Also from Brian and the team at sleuthkit.org are the Autopsy tools. Autopsy 2 was a Perl web tool. It's actually still pretty sophisticated, and it was amazing for its time. It allows you to do case and evidence management. It has some timeline and searching capability, and it can even use hash sets. Really, really advanced, especially for when it came out. More recently, and much cooler, we have Autopsy 3, which is a completely new program. It's a GUI front end for the SleuthKit 4 and all of its capabilities. Right now, it's really only supported on Windows. It's written in Java, but some of the libraries are pretty tough to get running. It's a really, really slick program. It has some of the same features that some of the expensive commercial forensics products have, including pre-processing and reprocessing evidence using plugins. And of course, since it's open source, you can write those plugins yourself or share them with your friends. It does a lot of artifact extraction. You can't really see it in the screenshot, but in that left-hand pane, one of the things that it's listing out there is all of the browser history, emails, chat sessions, and a lot of other stuff that it can just extract from the image on the pre-processing and ingress runs. Again, this mirrors and overlaps with the functionality of some commercial tools like Internet Evidence Finder, so it's really great to have this available from the open source community. It does have a full plugin architecture, not only using the plugins from TSK, but you can also write plugins just for Autopsy. There are ambitious plans to bring in a lot of the other open source forensics tools as plugins into Autopsy so they can share GUI and reporting and be a lot easier for people who maybe aren't Unix wizards to use. And it does have some timeline graphing capability that's still beta. And the last disk forensics tool that I wanted to talk about is Plazo. This is actually the new replacement for log to timeline, if you've ever dealt with that tool. Plazo is an incredible toolbox of timeline and super timeline and forensic analysis tools. I could probably spend the whole hour talking about Plazo and all the amazing stuff that it can do. The slide text is probably pretty small here already. It reads just about every format that you can think of in the current release, including it can read all of the virtual machine formats right off the bat without any guff at all, and of course all the forensic disk formats, EO1, AF, and so on, and QCOW, QCOW2 for QU and KVM users. It has parsers for an unbelievable number of things. I'll try and show you a better list in a little bit in the demo, but it can certainly read everything out of the file system, FAT, NTFS, whatever. Registry keys, the Windows event logs for multiple versions of Windows are all supported. Application logs and caches, the prefetch events, all kinds of crazy stuff that goes on in Windows systems. There are parsers already available for. Plus, it's open source, so hey, help out, write another one. The main utilities for Plazo, besides log to timeline, are obviously named things like psort, pinfo, preg, and the not quite so obvious plasm, which I think is used for tagging. It does have filtering support, not only by time or by tagging, but also by just arbitrary queries. You can pretty much just use SQL. And it outputs to almost every imaginable format. By default, it'll do its own SQLite zipped format. And then when you ask queries, they come out in CSV. But you can also get XML output, you can get text, you can create a database for the forensics time utility. And one of the niftier tricks it recently developed is you can actually load data from Plazo directly into an Elasticsearch cluster to use the ELK functionality that all the hip DevOps kids, are probably talking about right now on Reddit and Hacker News. For those of you that don't know, Elasticsearch is this amazing free searching and data warehousing stuff. not really qualified to explain it to you beyond a certain level. But what it allows you to do is to collect all of the data, not just from one case, but really from as many cases as you feel like you'll be cluster servers to hold. And it makes just some amazing things available, like the ability to build a data store for your forensics operation and throw every case you ever work into it, and index them and search them all together. Not only to look for indicators, obviously, between multiple cases, but also to do some of that fancy big data analysis stuff, right? So look for trends and clusters in the data that wouldn't be apparent if you didn't have them all in the same system all at the same time. And you can get Plazo from Plazo Kitaland.net, the homepage. It's also in Sift 3. Ah, yes. Let's see. All right, let me catch my breath real quick as we switch over to demo mode. Does anybody have any questions about any of the stuff so far?
It's big data.
Big data or data science is an idea that's pretty popular.
What does it mean to you?
Yeah, so that I'm going to refer you to the Udacity course. I'm not going to try and answer that.
What's a cloud?
Oh, the fluffy thing. It's water vapor suspended in the air.
That's where you want to put all your financial data. And that's where my pictures are?
I saved it in Word. Just for you.
Thank you.
So this is a Ubuntu Precise. It's a 1204 LTS, and it's pretty new. And then you can set up all of the Sift tools just by running a script that they provide, or you can just add the PPA and do it yourself. That probably all makes sense to Debian and Ubuntu people. If you use some other weird distribution, like something that never came from Red Hat, my apologies. There are some how-tos on the website, and get a real distro.
Well said. Hey, now in all fair, as a Debian user and previously, there are some redeeming properties of Red Hat-based systems.
Compilers that don't work. SE Linux is beautiful.
Linux.
Don't mistake me. The engineers at Red Hat are some of the most brilliant people on Earth, and they do amazing work on the kernel and the daemons and some of the most important subsystems. But their distro, it doesn't make me happy. Their networking scripts make me very, very sad. So along a lot of the other things that Sift pulls in, it actually pulls in Plazo and all the supporting libraries. This is a way easier way to do that than to try and compile all of the dependent libraries yourself. Open source community is awesome, and we have a lot of strengths versus some of the commercial outfits, but sometimes it hurts a little. The ability for every special snowflake in the digital forensics field to write their own parsing library for their own favorite format is a little bit like the fact that anybody who wants to can write a tactic code, a new exploit, and throw it in, and maybe HC will include it in the next Metasploit. But without Metasploit, that stuff's not very useful, right? So if somebody wrote a Python library to do something cool in digital forensics, chances are it's probably already included in Plazo, or they got it in the roadmap for the next release. But to build this stuff yourself, you need all of those libraries. And it's just an amazing variety of cool libraries for specific things, like event log parser, and not just the registry, but like something specific about the registry. There's a Python library for that. And part of the work that they're doing in the one series of Plazo, now that they're past the first release, is they've actually put in an abstraction layer called the DFVFS, which is sort of like a virtual file system for digital forensic stuff, except it's way more than just files. Yes, sir.
Yeah, so maybe this is the wrong moment I stepped out for a second, but just for another project out there, I'm just talking about like the Metasploit of X. There was a new project that kind of just came out, Viper. I'm not the one behind it, unfortunately. But it's a framework for, I guess, like store different malware and binaries and exploits, but people have been really busy writing modules for it. So if you've got like exploit development scripts or malware analysis scripts, and they're looking for tons of modules that work in Viper. So it's kind of like that, just a framework to launch, I guess, tools that other people have been working on are kind enough to share. So wanted to throw that out there, it seemed relevant for the
Cool, thanks. Oh yeah, nice. So like all good open source programs, the Plazo utilities have nice usage statements. Hey. Okay, but I meant that. So this is psort, which allows you to basically do anything you want to from a Plasma storage file that you've already created. I've got a couple here. Oops. From some of my lab machines. This is an XP box that I used in VMware Fusion, and a Windows 7 machine from VirtualBox. I know, a really creative name anyway. So we can run pinfo against these Plazo, basically databases. They're SQLite databases in a zip file with some metadata. And it will tell us all kinds of crazy stuff about what it pulled out of the image. And these Plazo dumps are portable. And they just contain the metadata, so they're significantly safer to pass around, and about 1% or less the size of the actual disk image that you processed, which is handy a couple of different ways. So there's all kinds of stuff here about the source file and when it was processed, but what I wanted to show you is this list of parsers, right? This is all of the modules just built into Log the Timeline in the Plazo system that it ran against this thing when I processed this one a couple of weeks ago. Now there's some pretty basic stuff in here, like, you know, Mac times. Okay, great, little file system.
What's the Zeitgeist parser?
I don't even know.
All right.
I'll have to look that one up. But there's a lot of recognizable stuff in here. There's your Symantec logs, WinInfo, Skype, Chrome, Opera, McAfee, XChat, SkyDrive. I guess somebody must use that. WinLink parser just for LNK files, right? It turns out LNK files are actually kind of important if anybody's studied, what's it, Fire or that one, yeah. If you studied Flame or Stuxnet or any stuff in that family, you'll have a much greater appreciation for how dangerous LNK files are. OLECF parser. Now I know what OLE is, but I'm not sure what this module does, so I'm gonna have to look it up. But I just wanted to show you guys the incredible variety of parsers that are built into the thing. They come with it for free, and that you are all cordially invited to write more. Right? Any itch you want to scratch, any file format that you find that you're using, and anything remotely relating to forensics or malware analysis that isn't already available through Plazo, well, fix that. I mean, it's Python. It's not like it's hard.
So why is it from 1970?
I was wondering that myself. Let's look at the other one. Probably because I didn't set the hardware clock right.
Yeah.
You joke, but that's the kind of stuff you have to watch out for. We're doing future.
I moved the strikes from my 2 days line. It is clearly on.
Huh. Interesting. That's either because of the hardware clock from my virtual machines or something else interesting that I'll have to check on the Mac that I did this processing on at home. You can see the original source disk. Same list of parsers. Gotta find out what Zeitgeist is. Google Drive parser, UTempX, WinEvent. There's an SE Linux one. Yeah. It's already looking for SE Linux stuff. Very, very cool. Let's see, what else can we do in here? Here we go. Command line. Yeah. Image offset. Here we go. Check this out. 4,200,000 events that it generated just by running these parsers against this WinXP disk image that I use for various things. 3.7 million just from the registry, and then pfile stat, MSI events, Windows events, the OLE thing, and the link files, Chrome history. There was even some of that on there because I have used Chrome on that box. WinJob, I think this is like scheduled jobs. Java IDX, that's another one that if you're doing current malware analysis, it's a very popular topic. Harlan did some cool stuff about this. And then WinInfo. There's also a lot of other places inside a Plazo file you can put stuff, like you can pre-process a report and stuff it into the Plazo dump and go along with it when you hand it off to somebody. That's what these doors are. And there's all kinds of options about how to do different pre-processing. And of course, you don't have to run all those plugins. You can specify which ones you want to use. I just let it run all of them. It's a good demo. Let's see. Got it. Okay. So here's the output modules that are configured, again, out of the box in the stable version. That's what we've got here. The development feed already has the Elasticsearch stuff built in. Not only can you get, CSV and backward compatible CSV for old block to timeline tools, you can just get the raw Python objects if that's what you want. SQL for the forensics time tool, the Plazo storage file, and a bunch of other stuff. Like I said, you can already go to Elasticsearch, and I think some people are writing some other really amazing output plugins. So that's the ugly side of Plazo. Obviously, you can pipe all this stuff into different kinds of GUI front ends. Forensics Time is a really nice one that's available for a couple different platforms. And if you stuff things into Elasticsearch, you can use Kibana, the K in ELK, to look at the data in your Elasticsearch cluster. And there are dashboards already built to do that for Plazo. But I wasn't able to prep one for the demo and bring it out here on my laptop. Sorry. Right. Do it. Yeah. There we go. Yeah, that was Plazo demo. So here's some memory analysis tools we're talking about real quick. The Mandiant tools, and then Volatility and Rekall. Mandiant, now a FireEye company, is a pretty well-known incident response and forensics company, and a direct and dire competitor to SecureWorks. They provide some of their tools for free. They are not open source. They're free for you to use for most circumstances. You should read the license carefully if you have any concerns. On the back end, their agent and processing modules for memory analysis and host analysis is the Memorize tool, which you can go download and works on pretty much all major platforms, including Mac now. And then on the front end, they provide a tool called Redline, which is a pretty neat GUI tool for doing memory analysis or for looking at analysis that people have done. It has a lot of Mandiant-specific stuff, like it does their threat scoring, their MRI scores, which may or may not be much use to you. But it will allow you to look at the timeline of processes, a lot of the metadata about the processes, to do some reporting. And of course, if you have any indicators in the OpenIOC format, you can automatically scan against those when you load a file in. You can also use Redline to create collection agents. So if you've been dying to create a USB stick that steals memory from anybody who inserts it and runs a program as an administrator, Redline will get you there in 2 clicks. Hey, it beats having to write that code yourself. Next up, back in the open source land, is the already famous Volatility framework. Carl, I think, did a pretty cool demo on Volatility here at DC404 not long ago. Skeleton key security, right? Yeah. Volatility is amazing. I can do a whole presentation about all the cool stuff that you do with Volatility. I think I even have one, but not today. From just a few years ago, when analysis of captured memory was a black art, that only a few people would even dare attempt, to where we are today with free, open source, really sophisticated tools that can do pretty much every kind of basic memory analysis you can think of across almost every platform. The current version of Volatility not only analyzes Windows memory, but also memory from Linux and OS X systems. And I think I heard that you can use the Linux from Android in there as well, if you have the right headers. It includes not only the core functionality for looking at a lot of stuff that you might want to look at, especially about the Windows and Linux systems, and Mac stuff is coming along nicely. But just amazing, amazing plugins that come with the thing. And of course, again, open source, write your own. There's actually a contest at least once a year that they sponsor to get new cool plugins written that they have prizes for. Some of my favorite analysis plugins in Volatility are Screenshot. You're actually seeing it working over here. Mouse. There we go. So these are Windows systems that the guy who did the screenshot was using, and they captured the memory of with Volatility. So you just write a big multiple gig file out that's just nothing but the raw memory from these 2 systems. And this is Volatility's ability to reconstruct what those screens looked like just based on RAM. And in fact, this is an older screenshot. In the current version, it actually labels all the windows too, so it tells you which program it was. That is awesome. Volatility also currently ships a timeliner plugin, which will generate out some of the information you need to do a super timeline, like the ones we were looking at with Plazo. But you can get it just for memory. You don't actually have to claim the disk. It just pulls the MFT out of RAM that the operating system is actively using to allocate files. Very cool. IE history on supported platforms will do exactly what it says. It will actually yank the history for IE or any other browser that's using those libraries off the system and give that to you in CSV or whatever you need. There are a lot of malware analysis plugins in Volatility. The only one I put up here is Malfind. Malfind does a lot of different really cool things. You should read the masters and doctoral theses and people who wrote the plugin to find out all about it. One of the tricks that I know that it does and that I can explain quickly is it goes through either all of memory or the processes or offsets that you specify, and it looks for pages in memory that are execute, read, and write. Because anything that has all of that at the same time and is part of the operating system is deeply suspicious. And it can just look through an entire memory image and tell you every page that has those attributes and a lot more. That's just the barest minimum what Malfind can do. And Hashdump, probably popular here in this crowd of scruffy-looking individuals because it looks for hashed or plain text passwords in the registry or in other spots in memory in Windows and just dumps them to disk for you to handle responsibly.
You mean like TrueCrypt password for the...
That takes more plugins, but yes. There have been successful attacks with Volatility against TrueCrypt from live systems, which kind of feeds into the whole conspiracy theory thing about TrueCrypt that I ain't going into right now.
That was always on their website, though. It's like I don't think they even pretended to store like your password in memory securely. I think it was always like if someone gets on your box, your password's in memory. We don't pretend.
Yeah, without completely getting off topic, I will agree with the general point, which is that the TrueCrypt authors, whoever they might have been, wrote a lot of really good material that went with that program to tell you how you could use it safely and what it could and could not do. And if you follow those guidelines, it is an amazing, amazing, very effective tool. But there are a lot of attacks, including some known attacks, that TrueCrypt is not, at least not by itself, an effective defense against. Evil Maid, for instance, is pretty effective against TrueCrypt in most of the scenarios. Coming from Volatility, it's actually a friendly fork of Volatility, is the Rekall project. And the sanitized version of the story is that once upon a time, there was a branch of Volatility called Tech Preview, where they tried out new ideas, where they did some pretty heavy refactoring, broke a lot of stuff, and then fixed it again. And one of the reasons that they were doing that is because they were trying to get Volatility integrated with GRR, the GRR Rapid Response Framework, shared by Google, but it's open source. Years went by, and it didn't look like Tech Preview was ever going to get made the next release version of Volatility. Development was continuing on the main branch, development was continuing on Tech Preview, sometimes also just called the Scudette branch, because that was the name of the guy who was in charge of it. And eventually it was decided that they're never going to be able to get a merge, and they needed to just go ahead on their own. So Rekall is a fork of Volatility. It does some things differently. Most of those things are very, very cool. Because it's of its initial design purpose that they wanted to get it integrated into DRR, Rekall offers much better integration and is generally more Python-like, friendly to the Python community and infrastructure. I'm being deliberately vague there. One of the ways that we benefit from that is that Rekall gets along with and kits with IPython and its notebook capability. More about that in a second. One thing that Rekall does completely different from Volatility is profiles. In Volatility, you have to run KDebugger image info against the new image to find out what specific operating system it is, and then tell Volatility to use that profile, like WinXP SP2 x86. And if you don't tell it that, it can't really do anything useful. It will just laugh at you. Rekall takes a completely different approach. They don't really use named profiles at all, but you can call a specific one if you really want to. Whereas Volatility might support a dozen profiles for Windows and a few more for Mac and Linux. Rekall has hundreds and hundreds of them just for Windows because their profiles are specific kernel versions. And that's not the kernel for a specific version of Windows. That's a specific kernel version. They actually found some really reliable counters or internal versions inside the memory of the kernel of Windows, and they're relying on that to find out which kernel they're dealing with. And then their whole profile structure is based off of that. Also, the profiles are hosted online, for those of you who are doing forensics on a system that connects to the internet, or you can clone that repo locally and use it locally if you need to.
So with the profiles in, you're dealing with, like if you call tech support and they gave you a specific hotfix that's not generally published, it might have changed something from your kernel, it's going to
The exact version of the kernel, the build version rather than the product version, if that makes any sense. And they have a huge online repository of these things that people are contributing more to all the time. There's active research from the folks on the Volatility project, finding new ones as these new versions of Windows come out, both service packs and new releases and patches and whatnot. They go in and they interrogate them, and people volunteer new ones. And of course, the notebooks. As well as the web UI, which is actually based off the notebook code and isn't quite ready to run yet. And this is from one of the Rekall slideshows, or excuse me, one of their presentations, showing off their web console, looking at actually some Linux processes. I hope. Yeah. I mean, it said Bash over here, but then apt-get. Not too many people run apt-get on Windows. Let them say this. On Mac, sure, but not in a while. All right. This works. Awesome. If you see one of our friendly server types, I could really use some more water. Or a pint of Guinness. There's usually a picture around, but it doesn't look like we got that this week.
we got coffee, but we didn't get everyone's coffee here.
This is that better? Hit it again. Alright. Let's see if that's going to scroll okay. Yeah, we might get away with it. We'll give it a try. So this is an IPython notebook that I put together that follows along most of the research that a guy named Ian All from Tech Defense did in an amazing article that he posted on his blog. And he did this after he went to the memory analysis training with the Volatility developers, which they do a few times a year. It's a very, very cool thing to get the chance to do that. And so he had just gotten home from class and really wanted to try out the stuff that he learned. So he grabbed some Dark Comet samples. Dark Comet's a rat. It's a piece of crimeware. And from some AV databases online, and infected some systems in his lab to see what would happen and what he could figure out with his newfound volatility prowess. This is an IPython notebook, which is an amazing thing in its own right. If you've ever used something like Mathematica or maybe Maple, you might be a little familiar with how this works. Essentially, this is both code, documentation, and the results of that code when it executes. And it's all in the same document, it's all in the same namespace in Python, which just gives you an amazing amount of power. And the notebooks themselves are pretty portable. So you run the commands, you put your documentation in there, you save the notebook off, and you can hand that notebook to somebody else to run the commands. Or you can just make a PDF or a LaTeX document of it and hand it off to somebody for printing and publication. The fact that Rekall works with and, in fact, encourages the use of these notebooks is just a huge, amazing thing towards taking open source digital forensics from being a whole bunch of individual command line programs that you run to frameworks that you can really build workflows into. Putting that in a more hacker sense, it's a GUI. I can get people in the office to actually use it. You see some smiles, no laughter, no crying. Okay, fine.
So it's like Windows or Word, right?
Well, it does run on Windows. So here's some stuff about Rekall that I pretty much already said. So here's a few IPython commands to get Rekall set up. Mentioned was Python, right? So from Rekall import interactive to get an interactive session. And then I'm just going to Control-Enter to execute this block. If you saw really quickly, the dot went solid for a minute. That showed us it was processing. And the output is that we have a Rekall session, and it tells me where it is in memory. And then I'm going to initialize Rekall with this file name. And it's thinking. And hey, I got a Rekall session. Now I did all that so that we could rerun all the commands later in the notebook so you guys could see it all happen. Here's some stuff about how to do memory analysis. You don't care about it. So here's image info. We mentioned this. In Volatility, you have to run this before you can really do anything. The command's still there in Rekall. It's just not vital. And it pops right back up again. Some of this incredibly detailed, arcane stuff is the kind of detail that Rekall uses in each profile. Not the version of Windows, but the kernel-specific version, or the NT build. This kind of stuff, like this right here, I think, is actually the unique identifier in a human parsable format that they use about which specific profile we're using. And then there's the time of the capture, the time since boot, the Windows root, and a few other things. So when you're looking at a memory image, one of the first things you usually want to do is to see if there were any network connections, especially if you're doing malware analysis. For the one that Ian did, he actually did it completely offline because he wasn't trying to study the C2 or what the malware would do if it had access to a network. So there's nothing exciting in the net scan here, but we can still run the command. Unlike a lot of Volatility Rekall plugins, what NetScan essentially does is it just goes rampaging around in memory, looking at all of the structures where this stuff might be and ferreting it out and then putting it out in a format that we can use. So we get all of the existing or still around, even if they're closed, network connections. This is where they were found in memory. We get all kinds of fun stuff like it's a TCP/4 connection, local address, remote address, state of the port, and the associated process. If you're thinking in your head, hey, that looks a little bit like NetStat NAOB, well, it's intentional. A lot of the Volatility plugins, especially on Windows, are designed so the output of the plugin mirrors as closely the command that you run on a live system as possible, so you can match those outputs up. Really easy way to find out if you're dealing with a rootkit is to do that kind of stuff, right? You pull the memory, and you run a command against the memory, and then you run the command against the live system. They don't match up. If there's stuff missing, that's very, very suspicious. And you know, if it's network connections that are missing and they're to malware China.biz, you definitely have something you probably need professional help with. In IPython, you get the input and output box. Output is scrollable. You just click in the margin, so it doesn't take up as much space when you don't want it to. Beyond the network table, we probably want to look at the process table. There's a lot of different commands for doing this in these frameworks. PSXU is my favorite because it's so thorough. It looks at it's either 5 or 6 different ways that running processes might be recorded or might exist in memory, and it lists them all out on a table with all the processes. So you can then see which processes were visible to which technique to get a really good idea if a process is trying to hide. If it's visible in the regular process tables, but it's not in this crazy reverse linked list that Windows actually uses, not going to get into the implementation details, then that gives you a hint that somebody's up to something kinky.
So you'll catch an injected DLL.
The DLL would probably be inside the process, but the metadata about the process might have changed, and there might be a hint there. The later commands, DLL list and some of the others, are better for catching that stuff. But with memory analysis, like every other kind of forensics, you start with a giant haystack, or if you prefer, a pile of sharp needles. Thousands and thousands, if not millions, of sharp needles. So you, at least at the beginning of an investigation, if you don't have a lead going in, like if you don't know a little bit about what already happened, and you're just going in blind, you kind of have to throw a broad net to try and get a hook onto anything suspicious, and then you follow that down and you try and figure out why that happened. Was it malware? Or just Windows Update? Or was Windows Update malware? Go back to Flame. The two is so we'll scroll that. So you will see, if you're paying pretty close attention, another point here, if you just haven't looked at this stuff before, is that there are a ton of processes running on a modern Windows system, even one that isn't doing anything yet.
Really good way to kind of deal with that is to get outside your machine before and after you infect it.
Oh yeah, yeah. I mean, the analysis approach that you use is baselining and whitelisting, and some of these tools allow for that, but it's kind of an advanced technique. I'm scrolling through here on purpose. Oh hey, look, Order of volatility. There's this memory dumping program. He changed memory to record memory so that we could look at this stuff. And scrolling some more, there's the command shell. Those are a little suspicious on a Windows system unless you know why they're there, because, let's face it, Windows users don't use the command line because they're on Windows. VMware tray, what was it? Notepad. That's suspicious. Oh, hey. Okay, it's on screen now. Does anybody see an odd process? Run which?
DDL32.
Ah, indeed. Good old 1524. We're going to come back to that in just a second. That is, in fact, very interesting. Another process command that I find really useful with volatility is PS tree, because it shows us the relationship between processes, like who started what. This metadata alone is sometimes enough to draw suspicion. And if we find, dump it, wait, run DDL32?
Yeah.
Oh, has a notepad. Well, that's interesting, since it's not a DLL.
How does it,
Uh-huh.
How does a DLL have an XE as a child?
So yeah, so we found that one, and then we want to dig in on that process. It was 1524. Note the bit down, or do fancy Python stuff to extract the value and call it again. And run DDL.
It's running out of time.
You can just write it down. It's actually running out of app data, local temp, MSDCS. Really? Well, I find that pretty interesting.
That was legit.
Yeah, totally. So this is DLL list. It does actually list the DLL, so good for them. But arguably, the more important thing that it does is it gives you the command line that that process was executed with, which in this case gave us the path. And then here are all the DLLs that it linked, which if you're really familiar with Windows, you might have a hint that this is not run DLL32.
No, not at all.
Because there's a lot of extra stuff here, including some .NET stuff that really doesn't need to have, and it ain't stopping yet. So we'll scroll that. And then we look at the Notepad, which is 1896, and the command line was just Notepad. Okay, not necessarily anything. And again, a lot of libraries for just Notepad. Let me unscroll that one. Or no, scroll it. Yeah. There we go. And from here, you pretty much dig into those processes, either in memory or on disk, to find out what you can about them. For the demo and for following along with Ian, we skip ahead a little bit. If you dump those processes to disk and you run strings against them, yes, just strings, you quickly find the Dark Comet configuration variables. Check these out. That's pretty damning, huh?
Oh, and a no IP address. Isn't that special? You see, there's what Microsoft recently did to no IP.
Yes, and was done unto them. They had to give it all back and pay some money. It's sealed. We don't know if there was actually any money involved, but I think there's probably money. And another thing that I'm showing you here is that IPython is pretty slick. You can just bang out to local programs if you need to. Yeah. And in Ian's analysis, he goes a lot farther. One of the cool things that he finds is the persistence mechanism. Actually, in the first place anybody would look, in the registry. But, I mean, even in the registry, in the first place anyone would look. Look at that key.
Run.
I can't see it on mobile.
Oh,
HP local machine, software, Microsoft, Windows, current version, run. The absolute zeroth run key. The first one. There's hundreds of locations in the registry.
Yeah, well,
I mean, but for run keys, to execute a program on somebody's login or on system boot, there are literally hundreds of places you can hide it. Guys like Harlan and some of the other actual forensics experts spend their days finding out new ones and adding them to the tool.
Yeah, but the run key
this is like the first one.
Well, they had that key open, so they probably just ran from there.
Thing is, that key runs whether you're logged on or not. So if that was a server, he'd still.
Yeah. This is HKLM. This doesn't have anything to do with the user session. Yeah. I might say that here somewhere. And here's the actual value, which is it's called micro update because you don't want to give your registry key name something awful sounding like Chinese malware. .biz. But you can see that the path goes straight back to that typo named weird directory file. And in And in Ian's research, he actually, like I said, he keeps going a lot farther. He finds the keylogger files and the mechanism whereby they're created. And in the keylogger files that were being created while he was doing this analysis, he found the commands that he ran doing his analysis. So that's always fun. Here's a little bit on malfind. I mentioned that it's a really, really complicated, kind of crazy command.
Ooh, look at Notepad.
This is the Notepad. It's a little bit unusual for the memory pages of Notepad to be both read-write and execute. So this is the kind of thing that we can find with malfind. If you point it at a process or an offset, it'll just look there. If you don't, it'll trawl through all of memory, which will take a few minutes and output some crazy stuff. One of the other things you get out of malfind, disassembly.
Wow.
Oh, wow.
That's cool.
It is, if you can read this stuff, which is its own thing. By the way, as an amateur, that looks like crypto. Repeated adds to a register, different offsets. Anyway, that looks like block crypto to me, but I don't know what I'm talking about. And here's Notepad. Yes, disassembly.
Yeah, it's doing that a lot.
Uh-huh.
Wait a minute, didn't Notepad have a net connection open?
It doesn't in this example, but I think it might like to try. It certainly had the libraries that it would need to make one.
Yeah.
Also very unusual for Notepad, which is not generally a network program.
So this might be at least obfuscating the communication stream.
Here's a message box call that Notepad is able to make that malfind flagged. Sleep, also slightly unusual for Notepad. It's a syscall that you don't ordinarily create process, huh? Yeah, I'm not happy about that.
That's
Come on.
question about this. Let's say you've done your analysis, you've done all this. Can you export this just like in this form as a static report, so somebody else could look at it and go through it, but they wouldn't actually have to have the image to look at it?
Yep, this IPYNB file is a single file. I'll mail it out when I send the slots out. And they won't be able to re-execute the commands if they don't have the
But they'll see the
libraries for the data.
results and all that.
All the results and all the commands that you ran to get them are in there, which is why I think it's so cool.
So it's
for
kind of like
forensics.
self-documenting forensics analysis.
Exactly. And that's why I think it's so neat that Rekall supports it, and why I'm trying to get other tools into it. And I'm still scrolling. So there's a whole bunch of syscalls in here that Notepad absolutely should not have. But there's one more thing. If you read into Ian's analysis, where he finds out what the mutexes are that this version of Dark Comet uses, that's one of them. And is there one more? Oh, come on. Malfind is kind of verbose. Terminate process.
That was the terminating the process, the child processing spot.
These are just syscalls. Oh, there it is. There's the mutex. Easy mutex KH06. These are syscalls or active pages in memory that Malfind thought were interesting. And like I said, it's kind of graduate school as to why it thinks they're interesting. But you can use the tool and use it to guide your investigations. There we go. That was the one I was looking for. And one of the last things that Malfind finds about Notepad is it points us right back to that misnamed, mislocated malware file.
Wow.
And I'll scroll that. There we go. Yeah. And lastly, this Notepad includes the full path to its parent process amongst all the disassembly from Malfind. And then references and questions and so on. Anybody have any questions about IPython notebooks or the stuff that I just ran through very quickly? Ian's actual analysis. Where's my scroll bar? God damn you, Chrome. Where's my scroll bar?
It's right. No, you had it right there.
It's there.
It's over there somewhere.
That's
you guys
it.
see it?
Yeah, that's it.
Is extensive. Goes on for quite a while. He does share some Yara rules that he developed as part of his analysis at the bottom of the blog post if you're just there for the payload. But if you want to learn a little bit about memory analysis or volatility or dark comment, I really recommend reading through this whole thing. I'll send the link out. Actor. Oops. Cool. No time yet.
No, you're good.
Those are some tools and some demos to hopefully entice you into trying them out. The good news is that you don't have to try very hard to get these tools. Pretty much all of the modern digital forensics arsenal from the open source side is available in pre-configured Linux distributions. The one that I'm using here is called Sift. It's put together by the SANS Institute for their courses, but it's freely available to anybody who needs it. Another really popular one is called Deft. And these are just pre-configured Linux distributions that already have all these tools ready to run. They already configured all the library dependencies and set up all the config files and all of the annoying Linux crap that we all love, but we don't necessarily need to do in the middle of a live investigation. Another really amazing distribution and collection of forensics and analysis tools is the Security Onion. Security Onion not only includes pretty much all of the network equivalent of all the tools that I just showed you, like for network forensics and for host forensics, it also includes all of the sensors and monitoring programs and servers and databases to set up your own monitoring capabilities and your own sensor networks. All from open source, all ready to run out of the box, also based on Ubuntu. And for the more advanced practitioner, there's a Linux distro called Remnix, oriented towards the reverse engineer and binary analysis, file analysis tools. That's put together and released for free by Lenny Zeltzer, who writes and teaches the malware analysis course for SANS. But it's completely open source. And I would be remiss in not mentioning the free attack tools, right? Kali, Backtrack, and lots of other people mentioned Viper.
Yeah.
Very cool.
Yeah.
All this stuff is open source. It's freely redistributable. It's free to download. In some very rare cases, you might need a free account from the site before they will give you a link to download a 4 or 5 gig file. I'm a libertarian, but I've also had to pay my own bandwidth bills, so I can kind of understand their perspective, right? Putting a little bit of a gateway there, free account, throwaway email address, they don't care. You just have to go through the registration process before they will hand you off to one of their Amazon cloud instances to use up a whole bunch of their bandwidth to get free stuff. Not a bad trade. And all this stuff runs on pretty much all the virtualization environments. It runs fine on VMware Server or ESX. It runs pretty well on Fusion. It does pretty well on VirtualBox. That's what I'm using here today. I hear there's another virtualization solution that is popular with some people, and it probably works fine on there too.
KVM?
What?
KVM runs on Debian?
Microsoft version. I tried it once.
Oh, you're giving me flashbacks to work last week.
Last week.
That's when I found out. I haven't recovered yet, but that's when I found out. I was doing some workflow analysis with the thing about a thing that I obviously can't talk about. But one of the answers to one of the questions was, oh, yeah, I have Windows 7, and it came with Virtual PC and WinXP, so I use that. And to close out our talk about free stuff, there is tons of free evidence available for you to practice with these free tools to learn how to do this stuff better and to possibly pursue a career in digital forensics. There are tons of images, disk images, memory images, network captures available at a lot of sites just for public download. HoneyNet, which is an amazing organization that you should have already heard of because of the work they do, did a whole bunch of forensic challenges, I think starting in 2001 and then for a few years after that. All those files are still up there. There are images of Linux and Windows systems, disks and memory, packet captures, all kinds of stuff. There are tons and tons of online CTFs. Some of these are actually like a real thing where you have to register and then they show you the questions and you have to submit answers. And some of them is just where somebody put up all the stuff and you can just play with it. Plus, a lot of the public CTFs post their challenges later after the competition's closed. So tons and tons of information there. Another really good source here, though sadly it has passed from the world, was the DC3, the Defense Cybercrimes Center digital forensics competition every year. Some of us who did participate have some of those files. There's some really good samples and problems to work there. The HoneyNet stuff, the CTFs, and the stuff from challenges not only gives you sample evidence, but there's like a question, right? There's like a crime or something in that evidence that you need to try and figure out. And there are probably spoilers available or help available from other people who have worked the same problems if you need it or if you want it. Or if you just want to go hop in an IRC channel with people who have probably beat through it already and commiserate. There is a huge archive of digital forensics cases, complete with case studies and evidence sources at Digital Corpora. This is supported by some, I think, NSF grants, and it's an amazing, amazing resource. On the network side, the Wireshark Wiki and PCAPR site and a few other really cool sites have PCAPs of all kinds of things freely available. For the Wireshark Wiki and for PCAPR, that's mostly innocuous things. If, on the other hand, you need PCAPs of malware, well, Contagio Dump and the malware public cuckoo instance will hook you right up and let you download lots and lots of PCAPs of malware, either downloading and executing or communicating with its friends for you to analyze. And the other side of this, of course, is the tools to acquire all this stuff are also free and are included in the same toolkits. So you can go capture your own memory on systems that you own. You can capture your own disks or those of your Atlas roommates if you own.
Wait a minute, own as in possession or own as
That's an O, not a 0.
Systems that you're responsible.
You can capture memory and disk from systems that you actually own and have the legal right to capture from.
Which actually can be tricky. Might be its administrator not have the legal right to capture from.
That's why I went with on systems you own. This was also given at work, and that was more clear to them. I didn't want the intrepid analysts on our team thinking that this was giving them free license to go run a bunch of capture tools on production systems, because that is not okay, and I would be upset. Touched slightly, but also upset because I'd have to investigate.
You have to get a letter from the authorized C-level person.
Essentially, it's the same get out of jail free card that you might need for a pen test. But from the perspective of the presentation, do this stuff at home. Free. Just download it.
It's not like
hypervisors are completely free, even open source. You can use KVM, and you don't even have to ever talk to VMware if you don't want to. And then you can run all the acquisition tools, you can run all the analysis tools, and you can simulate attacks in your lab and record everything that happens. Not only disk and memory and the host forensics that we've mostly focused on today, but network forensics and even up to the point of reversing malware for fun at home. So let's do that. I don't know what to tell you. So to wrap up, I think DFIR and digital forensics is just an amazing and awesome thing. And I'm really happy that I was able to get into the business and that it's my career now. It's a science that you can learn for free without endangering yourself or your pets. That's pretty cool.
Maybe not endanger your pets.
Compared to other forensics disciplines, digital forensics is much, much more pleasant and forgiving. For one thing, no dead things smell. For another, somewhat more serious, physical forensics, you really usually only get one shot to do a kind of analysis on one piece of evidence. And if you screwed it up or the evidence was compromised, that's it. Digital forensics, most of our evidence, as long as we're a little bit careful, is almost eternal, and it's infinitely duplicable and shareable, right? Whether you're talking about a file or an entire virtual machine cluster, as long as you have a little bit of skill with computers and you're a little careful, you know, measure once, measure 2 or 3 times, and then maybe times. You can keep trying over and over again. not only to get a result, but also just to refine your techniques. You can run your new skills that you might have learned today on evidence and or roommates machines that you captured back in the 20th century. You still have the files. The modern tools will read those formats just fine. You may be able to find stuff out. One of the neat things that some of the folks that have been in the memory forensics field a long time have done is they went back and they found one of the original memory forensics challenge files that was part of a competition that year in, like, I don't know, 1998 or something, and it was a memory image of a Linux server in an era when there were no tools. That the people who were actually doing this analysis were going to have to write those tools or do it all from a hex editor. And they threw a modern version of Volatility at it. And it kicked out screenshots and timelines and just all kinds of information about that system that wasn't possible to find out with the tools of the time. And that's just amazing, right? That's not true of any other hard science. Chemistry, your reagents age, especially if they're exposed to light or oxygen UV or water. Don't expose the sodium to water, by the way. I hear that's bad.
Can't do it more than once.
Don't eat the potassium. Be careful getting the magnesium hot. Sorry. Lab flashbacks. But I mean, there are a huge array of sciences. And science, all science is great. But this is one of the few that I think you can really get into kind of for free. Your own labor is not included in this cost. And pretty safely, as long as you take a little bit of care. You know, Boy Scouts who do, or high school students who do a digital forensics project for school might have an interesting conversation with their principal or the network admin, but they're not going to have to talk to the men in the black vans like the high school student who built a nuclear reactor. They really wanted to know where he got the fission pulse from. The plans for the reactor, that's public information, they can't really do much about that, but they really wanted to know where he got the fission pulse from, and they were not looking for the, I got it from some Libyans in the shopping mall at midnight next to the Twin Pines shopping mall, right next to the photo booth. Wow, okay. You and me.
No, we got it. We got it. And did you drive up in your DeLorean?
There we go. Okay, cotton underwear. I think we're synced up now. And the other thing that I think is really important and awesome about DFear is, as I may have mentioned or you may have gathered, I do incident response, and I've been doing incident response full time for years. Without forensics tools and forensics processes, it's impossible. We would never be able to figure out what has happened in some situations. I mean, I'm dealing with a case, kind of wrapped a case yesterday. Can't say a lot about it, but we were able, coming from two different directions, to figure out essentially when the bad stuff started happening and to figure out who might have been on the system at that time based on hard drive forensics and network logs. And it was months ago. If not for forensics, that information doesn't exist anymore. We didn't have those network logs. That stuff wasn't still in TFS, lurking in corners. We just wouldn't know. And we wouldn't have been able to conclude the investigation, and we wouldn't be able to, prosecute the guilty and change the way some things are done, and so on and so forth. So digital forensics is a key part of incident response, which is why a lot of people, including myself, include it in the name of the field. We refer to the field or our profession as digital forensics and incident response, as DFear. And I think it's really, really great, and I hope you guys are as interested in it as I am. Go download some of this stuff. Try it out. If you have any problems with any of the tools, or if you get stuck on one of the challenges, throw a mention out to DC404 or reach out to me directly, and I'll do what I can to help. Thanks for your time. Does anybody have any questions about the presentation? Oh, I got hands. You guys use hands? Oh!
Just a quick question. Sorry. Do you do this, like, you have your own company you do this, or you work for somebody and you do that as part of the group?
I am a security engineer at an online company where part of my responsibility is that I'm the senior incident handler. I'm working on getting some other people past that exam, so it doesn't have to be all me all the time. Because I really like to stop doing Windows forensics because I don't actually like Windows. Before that, I did a bunch of sysadmin work. I don't currently have a consultancy where I do this stuff on my own. As I mentioned at the intro, you might not have been here. I am not a forensics expert, and I barely know anything about this stuff. This is actually more of a hobby to me, and one that I had long before I was in the computer business and before I was a security professional. I've always been fascinated by this stuff, by these tools and what they can do and what they can tell us, as well as the scientific aspect of it, right? Because, yay, science beats all the other stuff. So, no, I do some training and some education stuff on the side. I am supposed to grade some exams this weekend for an online software testing course from BBST. There's a foundation section I'm helping teach this month. And I do teach as a mentor for SANS a couple times a year. I would not volunteer myself to help anybody with their investigation directly, but if you need help with the tools or getting the capabilities stood up, or in terms of educational consulting, you know, what classes or what college degrees or whatever make the most sense if you're interested in this field, I can absolutely help you out with that. And that's the down there. But backing up a couple steps, was there another?
Yeah, I had two, but I'll go back to one. You know, it is. I was going to ask you, like, how long do investigations actually have? Because often the deadline controls what analysis you can do.
It absolutely does, though there are some scientific principles that can help you figure out when to stop. But most of the time, you have to stop before you want to. This is one of the things where coming at this from an incident response perspective, rather than from the lawyers are paying you to do this perspective, makes a huge difference. In incident response, I'm trying, I don't always get to do quick things to inform the response efforts, right? Because response is happening in real time. If I claim the disk and I'm processing it in with Plazo or loading it up in Autopsy and it's pre-processing and that's going to take, you know, a week, it might, then that's not helping out with an active infection on our network, hypothetically, that we're trying to track down and root out, right? So the outcome and the timeline absolutely influences which techniques that you choose to use and how you decide when you're done. In an active case, you're trying to do things quickly or at least under constraints. One of the things that worked really well this week is after the arguments died down, I would announce an investigation plan. And it's kind of a basic sounding, sort of preschool sounding thing, but it's basically, here's what we know, here's what we don't know, and here's some ways we can try and find that out. Here's how long I think it would take to answer those questions. And then, hey, boss man, you know, which of these do we have time to do? Can I spend the time on? Whether it's, you know, my manager or the person that you're working for in a contract or a legal setup. And by pretty much explaining the experiment that I wanted to run and what the results would look like and how I would, and you know, bounding it that way, I was able to convince them to let me do more than I probably would have been able to get away with otherwise. And that experiment was extremely successful. I kind of wish I could talk about it in a lot of detail, but I was able to take a copy of a server that happened to be virtual, so that was lucky. And I stole a copy of it blatantly and gave it a new IP and loaded some monitoring tools on it and very quickly had it beaconing just like the infected host. The difference was I had monitoring tools on it, and essentially I spent a couple of hours Thursday afternoon reading through Process Monitor trying to figure out which of the crazy things that Internet Explorer was doing were normal crazy Internet Explorer things and which of them were extremely suspicious and indicated a rootkit called PlugX. Yeah, man, does I-9 do a lot. A lot of one of those hours was spent with, you know, it's not even a suspect system, the infected system that I have the monitoring stuff on in a controlled environment, the lab box, if you will. And then over here on my laptop, running Process Monitor against IE, which I never run on purpose, but you know, it's there. And watching what it does and all of the crazy things that it does and what that looks like in Process Monitor. Process Monitor is part of the System Internals suite, one of Percentavich's amazing free tools.
Awesome tool.
Really, really amazing. It is a tad verbose. If you don't filter the output, it will basically show you every bit that a process tries to twiddle. One of the first things that you probably want to filter out is the event logs. because essentially everything else the process monitor is telling that you is happening, it's also writing the event log about that, so that'll cut down on your log a lot. But yeah, the timeline and the time sensitivity of your operations, very, very important. You know, the difference between I have a live case, this evidence just came in via FedEx, we need to tell these people in this other office what to do, like we needed to tell them last week, but the evidence just came in via FedEx. Wish I was joking about that. Versus, hey, Harlan or one of these other geniuses released a new version of a tool, and Microsoft never seems to stop making versions of Windows. This is what I do for fun on weekends. I'm going to go load up this new tool and load up some Windows 8.2 or whatever version we have to deal with now, and see how it works, and see what's different. And the guys at that level, the ones that write and maintain these tools, spend a significant amount of time doing that kind of comparative analysis, looking at new software or new tools to figure out what kind of weird stuff it does now, and how that looks from a forensics perspective, and what the tool should do to capture that information. Did you want to go and then he'll do his other one? Or?
No, good. No, another question.
Oh, yeah, the follow-up. Thank you, by the way. That's awesome. The follow-up is more practical. We have a squirrel. If you were to have a squirreling instance on Amazon EC2 or a Rackspace Cloud, what's step one to getting into the forensics tool?
We're doing forensics on a third-party file service provider infrastructure. Or flip side, because you're a online provider, when your clients come to you and say, hey, we've got an investigation and we need your assistance because we don't control the infrastructure.
So clients don't do that too much, but sometimes LE does.
Right.
And you know, they need a well-formed and clearly detailed warrant, and then we give them whatever they need. Sorry, cop-out answer. Cloud forensics is a big, nasty, ugly thing. SANS has a class about it. I'm sure it's great.
So it's easier.
It kind of comes back to what's actually underneath there, what it's running on, and who controls that. So, you know, the same technology is involved if, say, TechOps runs a whole bunch of VMware stuff, and everything in the company, one way or another, is in there. And for security, I need a copy of some of that stuff. Well, in that sense, I have a business relationship with the IT department, and I say, hey, I need you to give me copies of all of this stuff. And if it's all virtualized, that's actually pretty good for forensics because it's captured already, essentially. In VMware terms, essentially all you have to do is snapshot stuff, and then you steal the files.
Are there cloud?
But the other side of it is where it gets a lot messier, right? If you know, if it's Amazon or somebody like, or Rackspace or somebody, and it's still VMware underneath somewhere probably, but you don't have any access to that layer, then it gets pretty hairy.
That doesn't change anything, right?
Well, it changes how you're going to be able to get access to stuff, right? One of the big things with forensics is the layer that you can see at. I mean, if you can shell into the box, you can zip up a directory of files that you're interested in, capture those files, and try and do some analysis against them. But if you don't actually capture the memory of the running processes, if you don't actually get the file system itself, the deleted files, the slack space, and all the other stuff that's there, there's just a whole bunch of stuff that you're never going to be able to know, and a lot of these different kinds of analysis techniques that are just not going to be available to you because you don't have the stuff to feed them. My answer there, besides the cop-out that I gave Ben, is you should really be asking these questions before you put important stuff on a cloud provider. It's like, hey,
if I need to do forensic analysis,
can I get
support?
Yeah, how much does that cost, and how quickly can you ship me copies of my stuff? Or, you know, do you have a cluster that you can move my load over to so that I can do analysis in your, you know, magical facility? And they may have some of that stuff, but if you don't ask, you'll never know. And I guarantee you it costs more, but I bet it's worth it. Because the alternative, some of these businesses or some of the newer businesses where everything's online all the time, they don't have data centers at all, it's all hosted with somebody else, is that you're not going to be able to do some of this stuff unless you get a lot of cooperation from people who aren't going to have any reason to cooperate with you, especially if there's no contractual language suggesting that they have to. You know, you're basically talking about them doing free work and bringing a lot of liability and risk onto their organization for no reason. So that's going to be really rough. But the technical details of the kinds of acquisition and the order of volatility stuff for the different cloud platforms, SANS actually does have a class about that stuff, which like all their other material, they update a couple times a year, so it's pretty current. If you're in that line of work, I would recommend that you look into that or something similar. There are essentially experts in that, and I am not one at all. Is that the same question, or I lost? Okay. Any other questions?
So I've got one for everyone, I guess. I have what's a very logical follow-up presentation to that. It's about malware analysis and reverse engineering. It covers everything he didn't and doesn't cover what he did. So like it doesn't get into a lot of memory analysis, but it gets into a lot of static and dynamic analysis, like disassembly, and it's like ready on my laptop. So if people are interested, it's 45 minutes. I don't know what the.
This book?
I've been talking about the book. I mentioned the book.
Cool.
So figured I'd throw it out there.
We got a slot open. Are we doing DEF CON next month?
We're doing DEF CON next month.
All right, so
DEF CON wrap up. How many people are going to DEF CON? Wow.
I couldn't get that.
So we're gonna have a DEF CON wrap up, and then yeah, we got to be out of here pretty soon. So that's almost 4 hours.
Are we doing a DC404 meeting in Las Vegas?
I don't know. Well, if somebody's going to want to organize that, but I'm not going to be there. So, who wants to volunteer to organize DC404? Is Taylor going? Anybody knows? Nobody knows.
you might already be there already.
Probably. Okay, so. Well,
all right. Well, thanks everybody.
Thank you, Edric. Okay, stop this.
If anybody's going to be in Augusta in September for the Security Onion Conference,